RISAFoundation utilizes a comprehensive set of modeling tools for the simple creation of a variety of foundation elements. Model elements such as grade beams, retaining walls, spread and combined footings, piles, and mat slabs. In this video, we'll take a look at the basics of model creation in RISAFoundation. So before we start modeling, I'm going to go into our settings here. And just on the codes tab, we can see the different code options for the different materials. We can also see that we can choose to set our selections as default so that that's the standard product defaults. Next, I'm going to go ahead and jump into our drawing tools. And here we've got a default rectangular grid. We can see the increments defined here in the X and Z direction. So I have 40 at 1 foot spacing. If I hover over a coordinate here, we can see the coordinate definition. I could also go ahead and change our type. So we have an option for a radial grid. And we also have the option for a DXF underlay. So we could bring in a DXF file and use that as our drawing grid. In this case, I'm just going to stick with our rectangular grid. And now we can go back to the Home tab. And before we start, I'm going to go ahead and open up our spreadsheet for our soil definitions. So in our soil definitions, we can use the default soil, or we could define a second soil or a third soil, whatever we need. So in this particular case, I've defined an additional soil. I could also define this additional soil by clicking on this ellipsis and actually defining depth properties. So if I had a geotechnical report or a borehole report, I could define individual layers of soil. So soil start depths, the weight, the skin friction, and we would use this for maybe the application of deep foundations. In this case, we're just going to stick with the basics here. And I'm going to go ahead and define a different soil region from our default. So I'm going to go ahead into soil regions, and I can now draw our soil 2 region. So maybe our soil 2 region is going to run in this area. So now I've got soil 2 in that area. Everywhere else that I would draw a foundation, I would use the default soil 1 in this case. So the next thing I want to do is I'm going to go ahead and start by drawing a slab. So we've defined the parameters of our grid. We can now go ahead and up into slab elements, click slab. The properties here shows the definition of that slab. So I can go ahead and choose the thickness. We'll stay with 12 inches. We can also look at the material. So we have a few different concrete materials here. If I go ahead and click on the ellipsis and I view the existing, I could edit this material. So I could edit the shear modulus, the density, all the design properties. I could also add a new one if I wanted to. So if I wanted to create some other concrete material that we didn't have by default. In this case, I'm going to leave everything the same. We'll use this 3000 normal weight concrete, and I'm going to go ahead and just start to kind of draw in by using my grid snaps in an L-shaped mat slab. So there we've got an L-shaped mat slab now. The next thing I'm going to do is I'm going to add actually some pedestals. So basically some points that I can put concentrated load onto this mat slab. So I'm going to click pedestals and post here. Again, we can see the definition of that element. So we can define the shape here. So if I expand it here, we can use a circular or rectangular. We can again define a material, set a design rule, and then set our height. So let's say our height's going to be 16 inches in this case. And then we can go ahead and just, again, using our snap points, start to drop in our pedestals at the locations that we want. I could also do something like add a thickened region to this slab. So if I click thickened regions, I can choose my draw option and say, okay, I want this to be 20 inches. And I'm just going to draw it kind of at the bottom here. So I've got this bottom edge that's maybe thickened. Now it's difficult to see this when we're looking in plan view. So if I switch to the ISO view, we can go ahead and see exactly where our thickened region is, exactly where our pedestals are in this case. So now if I switch back to our plan view, I want to add in another slab, but in this case, I'm going to use a circular slab, and I can use the circular slab generator. So we see the circular slab generator now open. We could define the geometry properties, including the coordinate, the kind of insertion coordinate. We could also define our line and area loads if we wanted to. So we could set a magnitude, 1 kip per foot here, and maybe 1 kip per foot here. And then we can go ahead and click apply. And so that gets applied up in that location. Again, if I go ahead and turn on my loads and look at it in ISO view, we can see the loads that we had defined there. So 1 KSF and then a line load here of 1 kip per linear foot. So jumping back into plan view now, I'm going to go ahead and add a few different types of foundation elements. So the first one maybe is a wall footing. So there's a few different types of wall footings. Let's just add a basic strip footing. And so again, when I go to define the strip footing, we can see all the information that can coincide with the definition of this strip footing. If we wanted to look at this in more detail, I can again click on the ellipsis in the wall footing definition and view and edit the existing wall footing. So I'm looking at this wall footing. I can define the thickness, the height, the construction of it. It could be masonry or concrete. We can define all the different wall details with rebar and all the different footing details with rebar, in this particular case for a standard strip footing. I'm not going to modify any of these right now. I'm just going to click apply, and we can go ahead and just model in a wall footing here. So now we've got that wall footing located there. The next thing we can do is the same exact thing for a spread footing. So if I click on spread footing, again, we'll see a basic footing definition that's default. I can expand this and view and edit the existing, again, walking through the same kind of parameters, general, geometry, pedestal, and soil for the definition of this particular element. We can see all this information, and for a pedestal or for a spread footing in this particular case, we'll set the basics for the definition of the the rebar, and the definition of the geometry, but the software is actually going to optimize these. So I'm going to go ahead and click apply, and again, I'll just go ahead and define a few spread footings. Next, if I wanted to connect those spread footings, maybe they're working in a lateral system with a grade beam, I can do that. So I can click on beams, and again, define my beam shape. So maybe I don't want it to be an 8 by 8, I want it to be a 12 by 8. We can define the start and end release, and then we could set a design rule if we want as well. I'm just going to go ahead and use the coordinate locations to model in my beam now. At this point, we've defined a variety of different footing options, from isolated footings to different mat slabs, different wall footings. Obviously, there's other footing types with piles and pile caps that we could create. But at this point, we could apply load, set up load combinations, solve the model, and then go ahead and review results. For more information on those topics, as well as other RISA Foundation related topics, please visit risa.com.